everyone, we are back, and today we are going to start our lecture 8, and we are going to talk about a different type of chi-square test, f-test, and then variable independence, specifically testing whether we have variables that are independent or if there's some correlation between the two. And this involves a lot of hypothesis testing and things that we've kind of touched on quite a bit before. However, previously we've done chi-squared goodness of fit test. And while there is some similarity to the work that we've done here, we're actually going to be looking at doing a lot of this work and a lot of this hypothesis testing now by analyzing samples based on their variance. And so this is a bit different from what we've done previously. So instead of looking at means now, we are actually going to be looking at variances. So this is our standard deviation, or this is our standard deviation here. A variance will simply be standard deviation squared, S sub x squared. So that's kind of the critical idea that we're working with here. So our metric is going to be this new chi-squared, which is analyzing and looking at population based on the variances that they have. So n minus 1, this is our sample standard deviation over what we're looking at for our population. So again, that's the null population here, standard deviation. So let's go ahead and let's look back at our material, and actually, let's go ahead and look at material A and see if the sample comes from a population with a standard deviation of 1.3 at a 95% confidence interval. So let's go ahead and get to it. So I'm going to go ahead, and calculate. So let's read in some variables here. Let's do library. And let's do tidyverse. Then I'm going to do, let's go ahead and do library, read Excel, just in case. Let's read in our material A. Where is mat A? Where is our material? Oh, here we go. So actually, I'm going to go ahead and set this as a working directory. So let's go ahead and do mat A goes to read underscore Excel, and then let's do, we're just going to read in mata.a.xlsx, and there we go. So that's going to be my material A. We can take a look at mat A, and we can see the values that we have here. So if we want to do any data sets, we can look at there. So let's go ahead and let's look at our, basically, our chi-square test. And again, this is our chi-squared goodness of fit test. So we're not really going to be working at all with some of these values here quite yet. So instead, we could look at f-test. F-test. Or you can do f-test. Here you go. Stats var test. So f-test compares essentially two variances. So you can actually kind of see x and y, so it's looking essentially at those data sets. But x and y have to be numeric values. So you can kind of, or you can look at the hypothesized ratio there too. So you can see some examples here where you do x and y and you're looking essentially at running the f-test there. So that's looking at your var test. You can do that there. Var test. So that's your var test, but again, we're not comparing two different samples there or here for this particular problem. So instead, let's go ahead and let's calculate and let's see if we get the same values here. So let's define our chi-square var equals a function, and it's a function of, let's say, n, s, and sig, and it's just going to be equal to squigglies n minus 1 times s squared divided by sig squared. So here's our chi-square var, and we can submit, or let's do length of mat A bracket 1. So that's going to be our n. We can also do SD of mat A bracket 1, because I'm just reading in that first column. And then finally, we can do our sig is just going to be 1.31. And we can calculate this, and we get 8.58 approximately. So that's our chi-squared value. If it's a chi-squared test, 95%, 0.05. Let's look at our length. What is our length of? Length of mat A, bracket 1. So that'll be 12, 11. So let's go ahead and look back at our little tables here. Look at lecture 6. So let's look at our chi-squared table. 0.05, 11, 19.67. I think that was true. And we definitely fall in the do not reject regime. So that's looking at this purely from kind of our handwritten method. Let's go ahead and let's solve this right now for basically, let's solve this using R, and let's actually calculate our p-value as well. So if we want to solve this with R, we are actually going to have to bring in an additional package because you see that our previous var test was only looking at 2 samples. So I'm going to have to do, we are going to have to do install.packages, and we are going to install nstats, environmental stats. This is actually a very, very good package. Has a lot of cool features. Let's do library env. Actually, we'll wait till it's finished here. Has a lot of cool packages and a lot of different statistical tools that we can utilize. So let's do env stats. So now we can do basically var test here. We're going to insert our material, mat A, and then we're just going to do this was a 2-sided test, basically, asking if it comes from 1.13. So our alternative is equal to 2-sided. Same confidence level, comp.level. It's very similar format. Confidence level, and then sigma dot squared, and 1.31 squared. So if we click on it, we see that our chi-squared is exactly what we calculated previously, which is excellent. Let's scroll down to where our 8.58. Good. We can see that. Let's see, our variance 8.58. So the variance is at 1.31. Because again, sigma squared. Degrees of freedom is 11. Excellent. P-value, again, it is not less than 0.05, so it must be in the do not reject, which is consistent. Fantastic. So we are in the typo here. Do not reject retreat. So, all right, let's go ahead and let's do another couple of examples to get our feet wet a little bit with this. I'm just going to erase this, but do not reject. Don't even erase it. So we'll see you all in the next video. Thanks.